Draw a square EFGH of side 4 centimeter. Mark 90-degree angle. Draw the locus of points at most 2 centimeter from the boundary of the square. So 2 centimeter from the boundary of the square is a parallel path. This blue path is a locus which is 2 centimeter from the boundary of the square. Draw the locus of point Q on the same side of EG as H so that angle EQG is 90 degree. Or we can say that angle subtended by the side EG of the square. So angle subtended by one line, and that is 90 degree, is basically the property of the circle angle in a semicircle, or angle subtended by the diameter. Here the diameter of the circle will be EG. To draw a circle, I need center of that circle and the radius, and the center of the circle will be the midpoint of this EG line. And you know from the property of the square that two diagonals of the square, they meet each other on the midpoint. This mark will be the midpoint of EG and it will be the center of the circle. So if the point Q is on this circle, semicircle, its angle from these two points E and G will be 90 degree. Wherever the point Q will be on this semicircle, its angle subtended by this diameter EG will be 90 degree. Hence, indicate on your diagram with letter P the region such that it is at most 2 centimeter from the boundary of the square and its angle EGH is greater than 90. The point P is at most 2 centimeter from the square. It means that the point P will be either on this boundary parallel path, or it may be inside of this parallel boundary up to the boundary of the square. And the second condition is that its angle subtended by this line EG will be greater than 90. This is semicircle. If Q is moving on this semicircle, so angle subtended by EG will be 90 degree, like this. But if this Q is outside the boundary of this semicircle, this angle is smaller than 90 degree. And if it is inside the semicircle, this angle will be greater than 90 degree. According to the condition, the angle is greater than 90 degree. What does it mean? It means that the locus P will be inside the semicircle. So just by fulfilling the two conditions, it should be at most 2 centimeter from the boundary of the square, and it should be inside the circle as well. The boundary of the semicircle will be not the part of the locus, because if the point P is on this semicircle, its angle will be equal to 90 degree. But according to the condition, angle should be less, should be greater than 90, and that can only be the case when the point P is not on the boundary. It should be inside the boundary. Let x degree be the bearing of the point P from G. By measuring the minimum and maximum possible bearing, fill the following statement. So bearing of P from G, we have to indicate that region by letter P. So P will be anywhere in this shaded region, and we have to find the minimum and maximum bearing from the point G. So I have just extended this line FG, so to get the north line, because I have to find the bearing now. and bearing is always clockwise from the north. So as P point will be somewhere in this region, and it will be the minimum bearing, because if you lift this line upward, the bearing will keep on increasing. So this minimum bearing will be 180 plus 45, that is 225 degree. But if the point P is here, so this will have bearing greater than 225. But if this point keep on coming over this at this point, so the bearing will keep on increasing. So for maximum bearing, the point P will be on this, it will be on point G or exactly near to point G, and for that the bearing will be 360 degree. Therefore the minimum bearing is 225 and the maximum is 360 degree.